Welcome to C# for Crestron programming. Crestron Ethernet Intersystem Communication, or EISC, is a great tool leveraged by many Crestron programmers to allow multiple processors or multiple programs within a processor to communicate and share data. Using an EISC with C# for Crestron is as easy as it is in simple Windows. We must choose the correct EISC to use based on what we are going to communicate with. We have a traditional EISC, the 3 Series EISC, the EISC server, and the EISC client. EISC is a UDP-based communication and is typically used for legacy systems, as they do not support the TCP-based 3 Series EISC symbol. If the system needs to have explicit control over the server and client using TCP communications, the separate server and client classes would be used. If you are communicating to a Crestron virtual control program, the virtual control is always the server, and the devices communicating will always be the clients. Code for this lesson is available in a zipped file download. We start with a new .NET Framework class library and bring in Crestron program files needed from NuGet. We need to add the using statement for Crestron Simple Sharp Pro Ethernet Communications to access the EISC classes. Adding all the different types of EISC is identical. Create your container. We now instantiate it here in the initialize method. Using the IP ID that matches what the other program is expecting, and exactly like the simple Windows symbol, we point at the other processor. Because we are using this to communicate between 2 program slots on the same processor, we are using the EISC loopback address of 127.0.0.2. This can be a string variable that is loaded from a config file or other method. It does not have to be hard-coded like this example. In order to get notified about any signal changes incoming on this try-list object, we need to subscribe to the event handler. We can also see there are other event handlers that can be used if needed. Online status change being one that has a high value to make sure your program knows that the communication is established and if it is broken. We now register the EISC with the control system using the register method. A best practice for all Crestron devices is to check if registration has a success before attempting to subscribe to the event handlers. We could do so by wrapping the register in an if that checks to see if we successfully registered. And if not, report the problem to the system or even attempt a different connection if unsuccessful. We now go to the SigChange event handler method and add code to detect each type of signal and create a reflector. This is the same as taking the symbol in simple and putting the signal name looped back around to send the signal back. Add in a print line so that we can see the information in the event. Compile and upload. I have already loaded the simple Windows program in another slot. Our connection is made, and if I send a signal from debugger on the simple side, we can see that the C# program has received it and reflected it back to our simple Windows program. Communication to and from a simple program also allows your C# program to communicate and use legacy Crestron hardware that does not have any C# classes to control them. Leveraging an EISC allows your code to communicate with simple code in many ways, as well as easily communicate to other processors across the network. Thank you for watching.